Humans are naturally curious and creative, two traits that have led our species to many scientific and technological breakthroughs. Since our earliest ancestors bashed a rock on the ground to make the first sharp-edged tool, humans have continued to innovate. The creation of stone tools is one of the earliest known human inventions, dating back to around 2.6 million years ago. These tools allowed early humans to hunt, gather, and process food more effectively. When they learned to use stone, fire, water, and earth, they began to develop as a species. From the debut of the wheel to the launch of Mars rovers, several of these key advancements stand out as especially revolutionary. Some inventions are thanks to one eureka moment, but most of our most pioneering inventions were the work of several innovative thinkers who made incremental improvements over many years. Here we explore 10 of the most important inventions of all time, along with the science behind the inventions and how they came about. The use of fire is one of humankind's most powerful early inventions and radically changed the way our ancient ancestors lived. Offering warmth and the ability to cook foods such as meat, the campfire was also a social gathering place. Fire also provided some protection against predators. The exact date fire was discovered has long remained a mystery, with some studies suggesting it was first used by hominins in Kenya 1 million years ago to cook meat. Other evidence suggests that Neanderthals in Europe and Asia harnessed fire, while Homo sapiens evolving in Africa mastered the skill of creating fire. More recently, archaeologists in Israel found evidence of hominin fire use dating to 1.5 million to 2 million years ago. Before the invention of the wheel in 3500 BC, humans were severely limited in how much stuff we could transport over land and how far. The wheel itself wasn't the most difficult part of inventing the wheel. When it came time to connect a non-moving platform to that rolling cylinder, things got tricky, according to David Anthony, an emeritus professor of anthropology at Hartwick College. The stroke of brilliance was the wheel and axle concept, Anthony previously told RevoScience, but then making it was also difficult. For instance, the holes at the center of the wheels and the ends of the fixed axles had to be nearly perfectly round and smooth, he said. The size of the axle was also a critical factor, as was its snugness inside the hole. Not too tight, but not too loose either. The hard work paid off, big time. Wheeled carts facilitated agriculture and commerce by enabling the transportation of goods to and from markets, as well as easing the burdens of people traveling great distances. Now, wheels are vital to our way of life, found in everything from clocks to vehicles to turbines. Ancient mariners used the stars for navigation, but this method didn't work during the day or on cloudy nights, making it dangerous to travel far from land. The first compass was invented in China during the Han Dynasty between the 2nd century BC and 1st century AD. It was made of lodestone, a naturally magnetized iron ore, the attractive properties of which they had been studying for centuries. However, it was used for navigation for the first time during the Song Dynasty, between the 11th and 12th centuries. Soon after, the technology spread to the west through nautical contact. The compass enabled mariners to navigate safely far from land, opening up the world for exploration and the subsequent development of global trade. An instrument still widely used today, the compass has transformed our knowledge and understanding of the Earth forever. The ancient Romans are credited as one of the first societies to use concrete in architecture, with Roman bathhouses and iconic sites such as the Colosseum and Pantheon Dome constructed using concrete mixed with volcanic ash, lime, and seawater. Incredibly, many of these ancient buildings are not only standing, but remain in good condition some 2,000 years later, a testament to the longevity of Roman concrete. However, the ancient Egyptians used a crude form of concrete in their buildings much earlier in 3000 BC, employing forms of concrete mixed with ash and salt water to create mortar. One study concluded that parts of the Great Pyramids of Giza might have been built using concrete. Concrete is strong in compression, but breaks easily in tension. So the invention of reinforced steel concrete toward the end of the 19th century in France, which lends concrete some of steel's tensile strength, enabled concrete to be used more widely in construction. The first battery dates back to 1800, when Italian physicist Alessandro Volta wrapped stacked discs of copper and zinc in a cloth, submerged it in salty water, and discovered that it conducted energy. In 1802, Scottish professor William Cruikshank invented a variation of Volta's design known as the trough battery, which consisted of 50 discs of copper and zinc in a wooden box filled with a salt solution to conduct energy. However, it was French physicist Gaston Planté who invented the first practically used battery in 1859. Modern variations on Planté's rechargeable lead-acid battery are still used in cars today. The invention of the light bulb transformed our world by removing our dependence on natural light, allowing us to be productive at any time, day or night. Several inventors were instrumental in developing this revolutionary technology throughout the 1800s. Thomas Edison is credited as the primary inventor because he created a completely functional lighting system, including a generator and wiring, as well as a carbon filament bulb like the one above, in 1879, as well as initiating the introduction of electricity in homes throughout the Western world. This invention also had a rather unexpected consequence of changing people's sleep patterns. Instead of going to bed at nightfall, having nothing else to do, and sleeping in segments throughout the night separated by periods of wakefulness, we now stay up except for the 7 to 8 hours allotted for sleep, and ideally we sleep all in one go. The ability for humans to fly has captured the imagination of inventors for centuries, with the first human-operated flight taking place in 1783 when Joseph Michael and Jacques-Étienne Montgolfier took to the skies in a hot air balloon. In 1853, British engineer George Cayley designed the first glider to successfully take flight, but it wasn't until 1903 that Orville and Wilbur Wright's plane became the first airplane to have a successful voyage. It not only took off from Kitty Hawk, North Carolina. Using its own power, it flew and landed without destruction, unlike many earlier aircraft inventions. The Wright brothers were inspired by watching birds in flight. The glider took a page from birds' wings but had a 32-foot or 10 meters wingspan. The Internet is a global system of interconnected computer networks that is used by billions of people worldwide. In the 1960s, a team of computer scientists working for the U.S. Defense Department's ARPA, the Advanced Research Projects Agency, built a communications network to connect the computers in the agency called ARPANET, the predecessor of the Internet. It used a method of data transmission called packet switching, developed by computer scientist and team member Lawrence Roberts, based on prior work of other computer scientists. This technology was progressed in the 1970s by scientists Robert Kahn and Vinton Cerf, who developed the crucial communication protocols for the Internet, the Transmission Control Protocol, TCP, and the Internet Protocol, IP, according to computer scientist Harry R. Lewis in his book Ideas That Created the Future Classic Papers of Computer Science, MIT Press, 2021. For this, Kahn and Cerf are often credited as inventors of the Internet. In 1989, the Internet evolved further thanks to the invention of the World Wide Web by computer scientist Tim Berners-Lee while working at CERN, the European Organization for Nuclear Research. According to CERN, the basic idea of the WWW was to merge the evolving technologies of computers, data networks, and hypertext into a powerful and easy-to-use global information system. The development of the WWW opened up the world of the Internet to everybody and connected the world in a way that it had never been before. Refrigeration in some form has been around for thousands of years. Depending on the climate, ice or cold water was used to keep food cold in ancient times. But artificial refrigeration didn't come until 1748, when the physician William Cullen first demonstrated evaporative cooling. Further breakthroughs came in 1834 when a vapor compression system was developed by American engineer Jacob Perkins. In 1876, German engineer Carl von Linde came up with a process of liquefying the gas, ushering in the era of commercial refrigeration. In 1913, American engineer Fred Wolf invented the first domestic refrigerator, and as demand for fresh produce grew, so did the number of households with refrigerators. Like many famous inventions, the X-ray was discovered by accident. In 1895, German engineer and physicist Wilhelm Conrad Röntgen was undertaking a 2-month study into the potential of radiation. In an experiment testing whether cathode rays could pass through glass, he noticed that the radiation was able to pass through screens of considerable thickness, leaving a shadow of solid objects. He soon discovered that X-rays could pass through human tissues to show a clear picture of the skeleton and organs. A year later, a group of physicians took the earliest X-rays on patients. These observations led to the development of radiology as we know it today, and have since helped medical professionals diagnose broken bones, tumors, organ failures, and more. Each of these milestones represents a fundamental change in human life and society, laying the groundwork for modern innovations and discoveries.